to another one of my Leetcode videos. In this video, we will solve Leetcode 581, shortest unsorted continuous subarray. And so what this is we're given an array, potentially unsorted, could be sorted as well, like the second example, but potentially unsorted, and we have to find the smallest continuous subarray, where if we sort that, then the entire array becomes sorted, and we need to just return the length of that subarray. So take, for example, this first example where you have 2, 6, 4, 8, 10, 9, 15. If you notice, if we sort the values between the 6 and the 9, just this subarray, then the entire array will be sorted. So since the length of this is 5, 1, 2, 3, 4, 5 elements, we output 5. In the second example and the third example, the array is already sorted. So, we don't need to sort anything because since it's already sorted, so the output is 0. And we have to solve this in O(n) time complexity. So obviously the naive solution, which is n log n, is we can just go ahead and sort the whole thing, and then compare. Once we sort the whole thing, we compare one by one the elements from both sides and see where they don't match, and then we can return the length of that non-matching index from the left and the right? So, but since that involves sorting, that will take n log n, and we have to solve it in just O(n) time. So in order to develop the intuition here, I tried to basically create a graph of these numbers. So let me show you what I'm talking about with an on-screen drawing board. So I'll just use this. So if we have a sorted array like this, right? If you graph the values, it's going to just keep going up, right? So you have 1, then you might have 2, and then you might have 3, and then 4. So if the array is sorted, the graph is just going to keep going up all the way, right? But if there's a portion of the array that's unsorted, you'll notice that the graph is probably it goes up, goes up, goes up, and then it might go down. Since it's not sorted, at some point it'll go down, and then there could be various fluctuations, right? And then it could be like this, right? So the intuition here is to find the points where the fluctuations happen. So it's going to be this point and this point, right? So it's going to be the point where we first dip and the point where we first rise from the right. And this basically tells us that, okay, that anything to the left of this point is already sorted, and anything to the right of this point is already sorted, right? So now we have a range to work with, but we simply can't return the difference between these two. And why is that? Because over here there could be something that's even taller than the longest one that we have, right? Or taller than something that's in between here. So then this element would have to be put maybe somewhere in between the two arrays, which is beyond this point, right? Or vice versa, we could have something that's so low that needs to be put over here. And so these points then would still need to be part of the sorting, right? Otherwise we can't just sort this part and be done with it. So let me give you an example. So imagine we have an array that's 2, and then 3, 4, and then imagine it is 6, 8, and then 5, right? So in this array, if you see it, it's continuously increasing from 2 to 3 to 4 to 6 to 8, and then it goes all the way to 5. But so let's say this is 2, 3, 4, 6, 8, and 5. So if you notice that the uh, 5 would be somewhere here, but if the 5 would be, this would be the first dipping point, right? Because it goes from 8 down to 5, but the 5 is is below 6. It's in between 6 and 4. So the 6 still has to be part of the array we sort, because the 5 goes over here, right? So how do we find this 6? It's basically, once we find this range, we find the smallest point in this range. So in this case, it's 5. And then we look for the first element from the start of the array that's greater than 5. So that way we can find 6, and we know that, okay, anything from 6 and beyond has to be sorted. And we do the same thing from the other side. So imagine again we have a graph. So let's say it keeps going up, but then it dips, and then from here we have something like keeps going down. Let's say it dips, and then you have like a huge value over here and another huge value over here, and then something like this, right? So these values still need to be, like, we then find the maximum and find the first index from the right side that's less than the maximum, and then we know we need to include that index in the array. And again, recapping, for the minimum, we do the same. We find the minimum over, and find this first element which is bigger than the minimum, and then expand it that way. So basically, and to summarize, we first find the first dipping point and the first rising point, and we mark those. And then in this range, we find the minimum and the maximum values in this range, and then we take the minimum, expand this part, we take the maximum, expand this part, and then with the expanded range, we take the how many elements are in this range, and that's our answer. So hopefully that made sense, but let's write the code. So yeah, so our first objective is to find the first rising point. So first dip from start, right? So we'll start by assuming it's 0, and then we'll say while we'll say if nums at first dip from start plus 1, and we do -1 here because we want to look at the next one as well. So if the next element is less than, since we want to look for a dip, is less than the current element, then we break, right? Because then that means we found our first dip from start. Otherwise, we increment this number. So now if the array is already sorted, there will be no dip, and our first dip from start will be equal to nums.length -1. So we'll say if first dip from start is equal to nums.length -1, this means the array is already sorted, so we just return 0. So this is our first dip from the start. Now, next thing we need to find is the first rise from the end, right? So it's a similar algorithm. First rise from end, we start by taking the last index, and then while first rise from end is greater than or equal to 1, since we'll be looking at the previous one, we do a similar thing. So we say if nums at first rise from end minus 1, which is the previous one, is greater than nums at first rise from end, then we break, because now we found our first rise. And then otherwise we do first rise from end minus minus. So this will find the first rise, and since we already know that the array is not sorted at this point, since if it was sorted we would go here, we know that there will definitely be at least one dip. So now that we have our first dip and first rise, we need to now look for the min and the max in that range, so then we can expand the range, right? So let's start by assigning the min and the max both to the first dip from start index, and then looping through the array to see if there's a better one. So we can start by first dip from start plus 1, I less than equal to first rise from end, I plus plus. So then we just say min is equal to math dot min comma nums at I, and max equal to math dot max. So this will give us the min and max in that range, and then we find the expanded range. So let's call the expanded range left and right, and our eventual answer will be right minus left plus 1, which is the number of elements between the two indices, right? So now we need to find, for left, the first element that is greater than min, right? So while nums at left greater than min, left plus plus, right? So sorry, while nums at left is less than min, we keep going until we find something that's greater than min. So sorry, yes, it should be less than equal. So even if it's equal, we keep going, because we can always place it at the end of those equal elements. And then similarly for right, so while nums, this should be nums dot length minus 1, sorry. So while nums at right is greater than equal to max, we keep decrementing the right, and eventually we'll end up with our range, our expanded range of left and right. This code is a bit long, but it's very simple to understand and straightforward, at least in my opinion, because it's very clear steps, like find the first dip, find the first rise, find the min max, expand the range. So let's go ahead and run the code. Cool, accepted, submit. Yep, we got an accepted solution. So thanks for watching. I'll see you in the next one.